I want to make a correction, okay, which is that. We've been talking about this whole calculus topic, right? So when you've got a function, and you take first principles or you use some other kind of shortcut rule like the ones I've been using, right? And what you end up with is the gradient function. And we've been calling this gradient function the derivative, right? The derivative because it comes from the original function, right? Okay, here's the important thing. This process, okay, to get the derivative, from the word derivative, you would think go from here to here, you derive, right? You do not derive. This process is not called deriving. This process is called differentiating. Now, I admit, two weirdo, techie sounding words, they both start with D. They seem similar enough, but they really are different things. So, it's a bit like, you know, when people have got cameras, right? And if you've got a big camera, like a, you know, legit, it's got a lens on it, it's black and it's heavy, that kind of thing, you can always tell a camera noob because they're holding it like this, and it's this huge thing, and like their wrists are sort of generally going down because it's heavy, right? A real photographer puts their hands underneath the lens, and their other hand is on the trigger finger, right? So don't make yourself look like a calculus noob by saying, hey, let's derive the function, guys. Because you'll say it like that, right? Please call it differentiating, because that's what it is, okay? All right, now, there was my first pet peeve point. The second thing I want to say is, we looked at the product rule, right? And we said, if you differentiate something which is a product of two other functions, right? U times V. You start with an UV, and you end up with a VUV, right? And we've been using this whole dash notation, okay? And here's the reason why. Dash notation is quicker, right? Because you can just write it, and it's the alternative is, let's think about what the alternative would be. It would be to say V times the derivative of U with respect to X, which is du on dx, right? Plus U times dV on dx. And not only does that take a lot longer to write, but you know, an UV into a VUV sounds a lot better than an UV into a Vedudix, a Duvdix, right? So, you know, just for the sake of memorability, we use this dash notation, and textbooks do as well, okay? However, I'm going to make a recommendation. This is the way I do it, except for the product rule, and the equation rule I'll show you in a second when you've got the result. I avoid this dash notation like the plague, okay? Here's an example why. Some places out there will teach you, okay, if I ask you to differentiate a function like this, okay, differentiate this. Some places out there will borrow from this dash idea, and they'll say to differentiate this, well, you write it like this. You take that, and then you dash it. That's the way they say it, right? And then you use the chain rule, and you put the power out the front, and then you reduce the power by 1. Now, can anyone tell me the problem with this, right? I defy anyone to see in their books if they actually write their ones in a way that they can distinguish from a dash, okay? And you wouldn't think it's like, oh, I clearly know that I'm differentiating here, and this is a number. Guess what? When you're under pressure, you end up with problems. And we were marking the Year 12 exams, Term 4 last year, and the number of people who were doing this kind of notation, and the amount of strife it was putting them in, the part of my soul was dying every time I saw someone put a dash like that, okay? So don't confuse yourselves. Use dashes for rules like that, just for the sake of brevity, but please avoid them when you're actually doing real working. And I'm going to show you why as we prove the quotient rule, okay? So, you might be thinking, far out, there's only like 3 minutes left. How are we going to prove the quotient rule? Is it as long as proving the product rule? The answer is no, because it relies on the product rule and also the chain rule. It's actually quite quick. Okay, so follow with me. There's the product rule. U times V are my two factors of my product. Well, a quotient is where you're dividing. Yes? So here's what I'm going to do. The great thing about having proved the product rule already is that to do this, I don't need to go back to first principles. Because a quotient is just a product in disguise, is it not? So here's the way I'm going to write this. I'm going to write this as the derivative of U times V to the power of minus 1. Okay? And you can see why I want to avoid dashes here where I can, because, yeah, it's just confusing. Okay? So I'm going to treat this as a product. So here's my first function, and here's my second one. Okay, so in the working out that ensues, apart from my final line, I'm going to avoid the dashes. I'm going to use the full-on v on dx notation because I think it's much more clear, less ambiguous. Let's go into product rule. It's going to be the second function unchanged. Okay, the second function is just v to the minus 1. Okay, and then you take the second function, sorry, the first function, you differentiate it, right? Now instead of writing u dash, which is going to look really weird with these minus 1s flying around, I'm going to write du on dx, okay? Because that's what it is. Then you take that first one and you write it unchanged, undifferentiated, so it's u. And then you take the second one, which is v dash, right? I'm going to take, my v in this case is v to the minus 1. So I'm going to differentiate v to the minus 1. All right, now, this first part here, that minus 1 just means put it on the denominator, right? So I've got du on dx all over v. Okay. Here I've got a u, he just hangs out there. When you look at this guy, right, this is why we prove chain rule first. This is a function of a function, isn't it? It's a function and I'm raising it to a power. So when I differentiate, what do I do? How does chain rule work? RIOT, right? So I'm not going to do any replacement. I think you guys can do it in your head. What's the inside function? It's just v, isn't it? So in a sense, there's already a replacement that's happening. Okay? So if I differentiate the inside, I get dv on dx. It's the derivative of v, right? That was differentiating the inside. Now I differentiate the outside. It's something to the power of minus 1. It's a power, right? So what do I do to it? What do I do? I bring the power out the front, so minus 1, and then I reduce the power by 1, right? V minus 2, okay? That's all the hard part. Let's tidy this up, okay? I've got du on dx all over v, right? Here, what have I got? I've got u times dv on dx, and this is, actually it's a minus, because there's a minus sign in here. And then this v to the minus 2 means divide by v squared. Two fractions, get them on a common denominator, namely v squared, which means I've got to slap another v up here. So I've got v times du on dx minus u times dv on dx all over v squared. So now I've done my differentiating work. Now I'm going to go back to my shorthand notation, okay, which is v, and that's differentiate u, so that's u dash. And then this is u, v dash. Now can you see, by the way, because this is subtraction, right? The order matters, big time, okay? So you can't just switch these around and like, is it vu or is it vu? I don't know, it doesn't matter, okay? Here it matters, you've got to have it in this right order. So when you have a quotient, you're going to end up with vu on v squared, okay?